new chapter, Chemical Bonding and Molecular Structure. Atoms. Under normal conditions, no other element exists as an independent atom in nature except noble gases. That means hydrogen atom, carbon atom, nitrogen or any other atom cannot exist on its own. So that two hydrogen atoms can combine and form H2 molecule. So hydrogen is available in the form of molecule. It is element and we call it dihydrogen. So the attractive force which holds various constituents like atoms or ions together in different chemical species is called chemical bond. So there is one kind of attraction between two hydrogen atoms so that they combine with each other, and that combination is known as chemical bond. Why do atoms combine? Why hydrogen itself is not available in the nature? Why H2 is available? We inhale air and normally we say that we inhale oxygen, but that is O2. We are not inhaling oxygen atom. We are inhaling oxygen molecule because in air oxygen molecule is available. So mostly you see everywhere they are molecules. And molecules are existing, not atoms. Why? Why hydrogen itself is not available? Well, there is always a misconception about existence of atoms. People consider that atoms are not available in their atomic form because they have not complete octet. Well, it is not the correct answer. The atoms are not existing because of octet? No, that is wrong. Anything is existing only due to lower energy state. That means Aufbau principle is very, very important. Hydrogen atom, it is having nucleus and electron. There is one proton and one electron, one orbit, one orbital, one s. So hydrogen atom has high amount of energy, and as it is having high energy, it is not stable. So H is not available. So Aufbau principle is very important, which gives us relation between energy and stability. That energy is inversely proportional to stability. That means if energy increases, stability decreases, or if energy decreases, stability increases. Therefore, hydrogen atom is unstable. Now, suppose these two hydrogen atoms want to combine with each other and form H2 molecule. Each one has one proton and one electron. So P1 is proton of one atom, P2 is proton of another, E1 and E2 are electrons of one and another. Now there will be repulsion between proton and proton. There is attraction between P1 and E2, and there is attraction between P2 and E1. Now what about E1 and E2? Well, there will be attraction because their spin is opposite. So there will be magnetic attraction between two electrons and electrostatic repulsion. Why? Because they have similar charge. But in this case, if force of attraction is greater than force of repulsion, then they would like to come closer. And when they come close, there will be overlapping of atomic orbital takes place. And in this overlapping, you will find two electrons. So this form electron cloud between two nuclei. And here you can see the distance between nuclei and electron is less. Therefore, we believe that the chemical bond is formed. And in this stage, well, this is the distance where nuclei are very close to each other. so that there will be repulsion more than attraction. So they would like to go away from each other. So there will be slight movement, and then atoms move away from each other and they will reach to distance r2, where attraction is greater than repulsion. This is r1 distance between two nuclei where repulsion is greater than attraction. Here we have r2 distance where attraction is greater than repulsion. So it will be a reversible process. Now these two atoms will reach to r1 distance from r2. Again there will be repulsion, so they will reach to r2 distance. So this way atoms continuously move from r1 to r2 and r2 to r1. Therefore we can say there is one distance, average distance r0, which is average of r1 and r2, where attraction and repulsion must be equal. Practically it is not possible to measure r0. Therefore we take average of r1 and r2 and it will be divided by 2, so that is r0. So we call it average bond length. Now we can understand this with the help of graph. Let us take two hydrogen atoms at infinite distance and their energy is high. Okay, they are somewhere here with high energy. Now these two hydrogen atoms, when come closer from infinite distance, when they are coming close to each other, distance between two atoms decreases. And which force is there? Attraction. And because of attraction, energy also decreases. So we have to move from right to left on x-axis and top to bottom on y-axis. So we are moving like this. So when the atoms are at this distance r2, there will be more attraction. So they will reach to r1, where there is less attraction and more repulsion. Again they will move to r2, then r1. So they keep on vibrating between r1 and r2, so that we can take average distance r0, where force of attraction and repulsion must be equal, and we assume that energy of H2 is minimum, therefore stability is maximum. So this way, two hydrogen atoms, when combined from infinite distance, they will reach to r0 distance, where the force of attraction and repulsion is equal and their energy is minimum, so stability is maximum. So if we consider this as a chemical reaction, then two hydrogen atoms are reactant and they form H2 molecule, which is product. Well, energy of reactant is very high and energy of product is low. But when reactants combine to product, energy released. So EP is less than ER, therefore delta E will be negative and energy is released, and therefore at this distance average bond length delta E will be negative. So we can say that bond formation is exothermic. Bond formation is exothermic. The stability of molecule is greater than that of atom because energy of molecule is less. So delta E is known as bond energy, when stability is directly proportional to bond energy. So bond energy is given in kilocalorie. Suppose we take hydrogen. The bond energy of hydrogen is 104. That means the difference of energy between H and H2 is 104. So when H combine and form H2, energy released is 104 kilocalorie. Or we can say that H2 is having 104 kilocalorie less than H. O2, double bond energy is 118. So energy difference between oxygen atom and oxygen molecule is 118. Or we can say that when oxygen atoms combine and form O2 molecule, there will be loss of 118 kilocalorie. And similarly nitrogen has triple bond and the bond energy is 226 kilocalorie. So nitrogen is at bottom. in all of this. So if you consider a graph, and we can draw like this, the difference between two hydrogen atoms and H2 molecule is 104. The difference between two oxygen atom and O2 molecule is 118, and difference between nitrogen atoms and nitrogen molecule is 226. So in this graph you can see that hydrogen is on top, oxygen, then nitrogen. Or we can say that the energy of N2 molecule is less than energy of O2 molecule is less than energy of H2 molecule. According to above principle, lower energy gives more stability. Therefore, nitrogen is more stable than oxygen is more stable than hydrogen. So, nitrogen is more stable than oxygen is than hydrogen. KosselLewis approach. Well, first group, lithium, sodium, potassium, rubidium, cesium. They are highly electropositive elements and they are known as alkali metals. 17th group, halogen, fluorine, chlorine, bromine, iodine, astatine. Highly electronegative elements and they are on the 17th group. 18th group or zero group, noble gases, helium, neon, argon, krypton, xenon and radon, and they are inert elements. Their octet is complete. In alkali metal, you will find one excess electron. In halogen, you will find one deficit of electron because there are 7 electrons in outermost shell. So Lewis and Kossel thought that these elements are unstable while all inert gases are stable. So they must be having approach of getting electronic configuration like inert gases. And that is why alkali metals should donate electron and halogen should accept electron, and normally it happens. So we assume that these elements combine with each other and form molecule. In the periodic table, the highly electronegative halogens and the highly electropositive alkali metals are separated by noble gases. Now, alkali metals, loss of electron gives M plus cation. Halogen, gain of electron gives X minus anion. Like sodium, it is 3s1 3p. When it loses one electron, it will be 3s0 3p, and the configuration is like neon. Chlorine, 3s2 3p 5. It accepts one electron and become like Cl minus, that is like argon. So sodium ion become a neon, Cl minus become like argon, and then they will combine and form NaCl solid. So stabilized by electrostatic attraction. Now electrovalent bond or ionic bond. The bond formed as a result of electrostatic attraction between positive and negative ions was termed as electrovalent bond or ionic bond. The electrovalence is thus equal than the number of unit charges on the ions. Ionic bond formation or crystal formation. Sodium solid plus half chlorine gas gives sodium chloride solid. How this reaction occurs, that we have to see. Well, first of all we take metal which is in solid state. So it is necessary to convert this into gaseous state. That is called sublimation. So sodium solid is converted to sodium gas by sublimation. It is endothermic process. The heat of sublimation of sodium is 108 kJ per mole. Then we take chlorine molecule. First of all, we have to carry dissociation of chlorine molecule, so we get chlorine atom. That is dissociation. Breaking of bond takes place. It is endothermic, and heat of dissociation is plus 121.33 kJ per mole. Now sodium gas, which ionized to give sodium ion. It is ionization, again endothermic process. 495.8 kJ per mole is required for this process. Sodium ion is in gaseous state, and it is like neon gas. So is it stable? Well, if you consider Lewis-Kossel approach, it should be stable, but practically it is unstable. Why? Because till we get sodium ion, we have given energy to the system. First is sublimation, it is endothermic. Second is dissociation, it is also endothermic. And this is the third process, ionization, it is also endothermic. So till now, we have given energy to the system. Therefore, when system has Na+, it is having very high energy. So though it has a configuration like neon gas, it is not stable. So Na+ is unstable because of high energy. Now, Cl will gain an electron and produce Cl-, which is known as anionization. Now it is exothermic reaction. So the fourth process is exothermic, anionization. Energy released is known as electron gain enthalpy or electron affinity. And chlorine electron affinity is 348.7 kJ. As it is exothermic, we put negative sign. So still the energy released is less than the energy given in the system. Therefore, even Cl- is not stable. So at the end, now we have Na+ and we have Cl-. These two will combine and form solid NaCl, that is crystal. So it is known as crystallization. And in the last process, energy released because of conversion of gas to solid and because of force of attraction between Na+ and Cl-. So energy released, and that is called lattice enthalpy, and that is minus 788 kJ per mole. And you can see this value is very, very high. So at the end of fifth process, if you will see, if you calculate, then overall energy released is greater than energy given. Therefore, NaCl is stable than Na and chlorine. So the fifth process is very important for stability, and we are getting crystal of NaCl. Remember, we write here 1 Na+ and 1 Cl-. But when the crystal of NaCl form, there is not 1 Na+ and 1 Cl-. There are n number of Na+ and n number of Cl-, and they combine and form NaCl. Now, when NaCl is formed from elements sodium and chlorine, if you make the total of all, we will get heat of formation of NaCl, which is equal to heat of sublimation plus heat of dissociation plus heat of ionization plus electron gain enthalpy plus lattice enthalpy. First three are positive, last two are negative. So negative is greater than positive. Therefore, overall 410 kJ per mole energy released when sodium chloride is formed. And this is known as Born-Haber cycle. And when crystal of NaCl form, this is not the whole crystal. It is the one of the unit cell or smallest part of the crystal, which we call unit cell of NaCl. And here you can see once Na+ is surrounded by 6 Cl-. And similarly, 1 Cl- is surrounded by 6 Na+. So, the unit cell of NaCl contain 14 Cl- and 13 Na+. If you take unit cell of NaCl, there are 8 corners and you have to put 8 Cl minus at 8 corner, and there are 6 faces and there are 6 centers of the faces. There also you have to put Cl minus. So 8 corner plus 6 centers of the 6 faces gives 14 Cl minus. This is edge of Q. There are 12 edges, so there you have to put this Na plus at the center of the edges. So 12 edges means 12 Na plus and 1 Na plus in the center of the Q. So total 13 Na plus are present in one unit cell of NaCl. So this is NaCl. Well, the point is Na plus and circles are Cl minus. So if you consider 1 Na plus, you will find 6 Cl minus are at equal distance from 1 Na plus. That is known as coordination number of Na plus. So in NaCl, coordination number of Na plus is 6 because there are 6 Cl minus. Similarly, if you take any one Cl minus like this, then you will find total 6 Na plus surrounding 1 Cl minus. And that is why even coordination number of Cl minus is 6. And if you join this 6 Na plus or 6 Cl minus like this, then it forms octahedral. Therefore, the shape of NaCl or geometry is octahedral. And in this you will find 1 Na plus around 6 Cl minus, 1 Cl minus around 6 Na plus. And therefore coordination number of Na plus and Cl minus will be same, that is 6. Now calculate the enthalpy change of the reaction. Sodium solid plus half bromine gas gives sodium bromide. Delta H atomization of sodium is given, atomization of bromine is given, first ionization energy of sodium is given, first electron affinity of bromine is given, and lattice energy of NaBr is given. And we know that delta H atomization plus delta H atomization of bromine plus first ionization enthalpy plus first electron enthalpy, first electron affinity plus lattice energy is equal to enthalpy change. So that is minus 367 kilojoule per mole. Which ions present in MgO? Well, Mg plus 2 and O minus 2. Calculate the enthalpy change for this. This is the reaction. Calculate the enthalpy change for the reaction. Mg plus half O2 gives MgO. What kind of enthalpy change is this? It is called standard enthalpy of formation of MgO. Why? Because Mg is element, oxygen is also element. Now, heat of atomization of oxygen, heat of atomization of Mg, first ionization energy, second ionization energy of Mg is given, first electron affinity of oxygen, second electron affinity of oxygen is given, and lattice energy of MgO is given. So it is the total of all. So 148 plus 1451 second ionization enthalpy plus 738 plus 249 plus 798 that is second and minus 141 for oxygen, and lattice enthalpy is 3791 and total is minus 548 kilojoule per mole. So the actual value for this reaction is minus 602 kilojoule per mole and theoretical value is 548 kilojoule per mole. Why? This is because there is a degree of covalent bonding in MgO. Therefore, the bonds formed are slightly stronger than those predicted by purely ionic model. This is example. Find the enthalpy of formation of MgCl2 using the following values. Here sublimation of Mg is given, ionization of Mg is given, I think both. Chlorine dissociation is given, chlorine anionization is given, so electron gain enthalpy, and finally lattice energy. And the answer is 207 negative. Now conditions for formation of ionic bond. First, number of valence electrons. Metal should possess 1, 2 or 3 electrons, while non-metal should possess 5, 6 or 7 electrons. Net lowering of energy. Sodium release 1 electron and become Na+, and it is 119 kilocalorie. Chlorine gain electron and become negative, and it release 85 kilocalorie. And finally 187 kilocalorie release when Na+ and Cl- combine. So when ionic bond is formed, at the end, lowering of energy should be there. Electronegativity difference should be greater than 1.7. Now factors governing the formation of ionic bond. Ionization energy. Lower the ionization energy, greater will be the tendency of the metal atom of change into cation. Electron affinity. Higher the electron affinity, more is the energy released and stable will be the anion form. Lattice energy. A plus combine with B minus and form A plus B minus plus energy release, which is called lattice energy. Size of the ions. The force of attraction is inversely proportional to the square of the distance between the ions. Charge of ions. Greater the charge on ions, greater will be the force of attraction between them. Lattice enthalpy. The lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of solid ionic compound into gaseous constituent of ions. The lattice enthalpy of NaCl is 788 kJ per mole. This means 788 kJ per mole is required to separate 1 mole of solid NaCl into 1 mole of Na plus and 1 mole of Cl minus to an infinite distance. Characteristic of ionic compounds. Let us take example of MgCl2. This is Mg atom and this is chlorine atom. Chlorine has 7 electron, Mg has 2 extra electron. So this 2 electron will be given to 2 chlorine. So each chlorine become -1 and Mg carry +2 charge. Or Mg can join with oxygen and Mg can donate 2 electrons to oxygen and there will be +2 charge on Mg. So Mg combine with oxygen and form MgO. Solids at room temperature. They are all solids at room temperature. All ionic compounds having high melting point because ionic bond is the strongest bond. They are hard and brittle. Like if you hammer this or if you try to break it and give force on one direction, these layers will slide, and when the layers slide, positive, positive, negative, negative comes on each other and there will be electrical repulsion. They will break it, and that's why they are hard but brittle. All ionic compounds are more or less soluble in water, like NaCl. When you put NaCl crystal in water, there will be electrical attraction between Na plus and oxygen of H2O and Cl minus and oxygen of hydrogen of H2O. And this electrical attraction is very strong, so they will break this ionic bond. So sodium ion is attracted by H2O oxygen and Cl minus is attracted by H2O hydrogen. Then Na plus is immediately surrounded by oxygen and Cl minus is immediately surrounded by hydrogen. So this is called solvation, and due to solvation ions remain stable in aqueous solution. Conductors of electric current. All ionic compounds in molten state or their aqueous solution can conduct electric current, and the reason is in molten state there are free ions. In solution also there are free ions. They do not exhibit isomerism. The ionic bond involved electrostatic lines of force between opposite ions and is non-rigid and non-directional. Therefore, there is no isomerism. Ionic reactions are very fast. Ionic reactions are fast in aqueous solution. Why? Because free ions are available in aqueous solution, so extra energy is not required to break ionic bond. Lewis approach. According to Lewis, when ionic bond is formed, the positive ion, it is a cubical structure, and positive ion remain in a center of the cube, that is, and anions or negative charge will remain at corners. So that is a positive kernel made up of nucleus plus inner shell electrons. And this sodium is unstable. Similarly, here we have argon. Argon is like this, that positive charge is in the nucleus and that is in the center of the cube, and electrons are kept at 8 corners because it has octet. Sodium has only 1 electron, so that is kept at 1 corner, and argon has 8 electrons, so we can keep these 8 electrons at 8 corner of the cube. So cubical structure of different element was explained by Lewis, and Lewis postulated that atoms achieve the stable octet when they are linked by chemical bonds. So if sodium has to achieve electronic configuration or stability, according to Lewis, it has to release this electron, mix this all corner of the cube empty, and it becomes like neon.